Welcome. Today we're going to solve by factoring. The first question about this example is, what do you know about x or y? Well, for one thing, since x times y equals 0, at least one of them must be 0 or equal to 0. So that is what we definitely know. And here are the basic notes that I usually give about solving by factoring. Get everything on one side so it equals 0. You want the biggest variable exponent term to have a positive coefficient. So we're looking for the biggest exponent for the variable to be, that term to be positive. You're going to get everything on one side, then you factor completely, and then you separate them, set them equal to 0, and solve them separately. So triple S. This top one is already factored for you. So this parenthesis times this parenthesis equals 0. So I'm going to separate the things that are multiplied together here that are equal 0. I'm going to set them equal to 0. And then I'm going to solve them. In this case, I'm going to have to subtract 7 from both sides. Add 15 to both sides. And you connect them with the word or. So x equals -7 or x equals 15, because it could be this or that or both. That's what the word or does, that conjunction or. Our next example down here is not factored, but it is already everything on one side equal to 0. So we're going to factor it, x and x. We're going to use our sign chart, first sign, second sign, gives you plus and plus. And pair of numbers that multiply to 6 and add to 5 would be 2 and 3. Then I'm going to separate set equals 0 and solve. X plus 2 equals 0. X plus 3 equals 0. Subtract 2 from both sides. X equals -2. Subtract 3 from both sides. X equals -3. Now another way you can answer this question without the word or, but implying it, is to say -2 comma -3. And that implies that these are the two possible solutions for x. So, or as a connector, or a comma between them when you're listing answers. Oops, too far. Here's another couple examples where they're already factored for you. So I'm going to separate and set equals 0 solve. 3x plus 4 equals 0. 2x minus 9 equals 0. And there's a little work here, so I'm going to subtract 4. 3x equals -4. Then I'm going to divide both sides by 3. X is going to be -4 thirds. Or add 9 to both sides. 2x equals 9. Divide both sides by 2. X equals 9 halves. That's the other possible answer. So -4 thirds or positive 9 halves. Down here, we have an example where this term is multiplied times this parenthesis. So it's already factored, and that term includes a variable. So we are going to set it equal to 0. If it did not include a variable, you could do something else. I'll show that in a later video, but you could basically ignore it if it did not include a variable. But in this case it does, so we are going to set it equal to 0. Here I'll divide both sides by 5. X is 0, or I'm going to add 3. 2x equals 3. Divide by 2. X equals 3 halves. Now 3/2, we know that's 1.5, so either one would be just fine. All right, so these are basic factoring. You give them a try and see what you can do. Go ahead. All right, now that you've done these two, you've paused the video to do that. I'm going to factor them. X plus and x plus. Pair of numbers that multiply to 20, add to 9. How about 4 and 5 multiply to 20, add to 9? So I'll set them equal to 0. And solve. Subtract 4. X is -4, or subtract 5. X is -5. On the other side, we're going to factor these, since it's already equal 0. X plus and x minus are our signs here. And a pair that multiplies to 20 but adds to 1. Now, in this case, it's -20 and -1. Our signs here are different, so we're looking for a pair that multiplies to 20 but differs by 1. 4 and 5 differ by 1. Well, it's a similar problem, but the 4 is with the positive, the 5 is with the negative. That's going to give us our -1 in the middle. Now I can go ahead and set equal to 0. Triple S, and solve them. Subtract 4 from both sides. Add 5 to both sides. So x is -4 or 5. Here's an example, or set of examples, where everything is not already on one side equal to 0. So this is what we're going to do first. We're going to find our biggest exponent term. Here's my exponent. Biggest term is 2, and that's the biggest exponent term. Currently, it is positive. So I want to get everything on the side where that is positive. So I'm going to add 18 to both sides. Please remember, when you do this, you're going to write it in descending order by exponents variable. Now I can factor, and there were no like terms, so I couldn't combine anything. Y plus, and that's going to factor into 9 and 2, multiply, add, right? 9 and 2, and then I'm going to set equals 0, triple S, set equals 0, solve, separate, y plus 9, y plus 2, sorry, not 9 plus 2, y plus 2, equals 0, and solve them. Subtract 9, y equals -9, ran out of room there, subtract 2, or -2. 9 or -2 are our two answers in this situation. Down here, I want to get everything on this side. There's my biggest exponent term, and it's positive, so I want to move everything over there. So I'm going to subtract x and subtract 6, add its opposite to both sides. This is going to be 0. Notice the left side was 0 this time, not the right side. X squared minus x minus 6. I want to factor that. A plus and a minus are our two signs. And we're going to keep, let's see, a positive 2 and a -3 is going to do it. Now when I set it equal to 0, it doesn't really matter which side the 0 of the equal sign the 0 is on. So put it on whichever side makes you comfortable. I'm going to subtract 2 from both sides. X is -2, or I'm going to add 3 to both sides. X is 3. There's my answer, -2, +3. All right, go ahead and give these a try. and see how you make out. Pause the video and unpause when you're done. In this first example, I'm going to subtract 17w. That gives me w squared, then minus 17w plus 72 equals 0. I'm going to factor this one into w minus and w minus, because with a subtraction sign here and a positive sign there, we're going to have two signs that are the same and they're both negative. Multiply and add. Because the signs are the same, we're going to add the two numbers to get the 17. 9 times 8 is going to be the pair that multiplies to 72 but adds to our 17. So I'm going to set them equal to 0, not x, w. Very easy to get into the habit of writing x all the time for your variable. W minus 8 equals 0, and now I'll solve that by adding 9, adding 8, w equals 9, or w equals 8. Nothing much, okay. Over here on the other side, let's say we're going to move this term to the other side. And that's because the biggest exponent term, which I just circled, is not positive. It's got a negative coefficient. So I want to add the opposite of that, a positive x squared, to both sides. So that gets me x squared plus 3x minus 40. Now I want to factor that. X plus, x minus, 8 and 5 differ by 3 and multiply to 40, so I want a positive 8 to get me positive 3 with the negative 5. I'm going to set each equal to 0 and solve them. Subtract 8, add 5, x is negative 8, or x is 5. Hopefully you got those answers. That's our assignment, but it's in Google Classroom, so off you go. Have a great day.